Well, hey everybody. So Dave here. So I was thinking about last night's class, and it was a good class. I really enjoyed it. You guys did a great job with the group activity where you brainstormed ideas for the test cases, and I realized that I struggled to manage the time effectively or use the time effectively. We had some great conversations, a nice long prime minister's questions. It was awesome to get all the observations and things you want to know about the cones all squared away. But I felt we ran out of time, and I'm looking ahead at the Wednesday class for this week, and I'm like, oh, there's a lot of stuff to cover. Plus, I want to do more tester and development. We wrote what one test case and got to pass, and so then I feel I need to do some more TDD, and I want to we want to do pair programming. And when we're all together in class, I want to focus on those things, the things that are interactive, the things where we can have a conversation about what we're doing. And so therefore, if I'm just sitting there lecturing at you or telling you about some handout or there's text up on the screen and you're reading it while I'm talking to it, that doesn't seem very interactive, doesn't seem like a very good use of our time. So what I thought I would do is record basically the part of tomorrow's class where I tell you about your projects and pre-record all of that. So you've got so I can go so I don't have to worry about like rushing through it. Of course, you know me, I'll talk fast anyway. Um, and then you'll be able to review that either before class, ideally, or after class in follow up. Um, and so that you can get any of your questions answered, and so that you have all the information you need to get started on your project one, especially before the long holiday weekend. I want to make sure that everybody sort of has a good idea of what the expectations are for the next couple of weeks, so that you can use your time effectively. Sound good? Let's dive into it. So I think where I want to start is just with the project one assignment. So we've seen the koans assignment. We saw the student assignment, but this is like the first real development project. As you may recall from the syllabus, the projects in this course come in. Let's see here. It's the winter, so it's 6 phases. This is so project one of six. And it goes all the way from writing some simple Java classes and parts of the command line all the way through to an Android application. And along the way, you'll work with files, you'll do some text formatting, you'll work with relational databases, you'll make a REST API with a web server, and then you'll do an Android application. But today, we're going to be talking about just project one, just getting started. And the theme for your projects, your application is going to be a phone bill. So basically, what you'll do in this first project is write the sort of fundamental classes for the project. You'll actually be using these classes throughout the duration of the course. And so then the phone bill and phone call that you write here in week two or week three, you'll be using throughout the rest of the course. So the goal here is that you'll work with classes that you didn't write. There's APIs and classes that you'll subclass one of my classes, actually a couple of my classes, and you'll work with those. And then you'll also be working with parsing what's coming in on the command line. And the command line format is a little bit more complex than the student program was, and I don't really know how this compares to your other classes. But just be clear, one of the big goals of this project is to parse the command line. So actually, before I go into the details of all the classes and stuff, let's create the project first, and that's down here, right? Yes. Okay. So then. Okay, there is a create first project script that's in your repository that was created from the getting started repository. So I'm going to go onto the PSU uh, Linux machines, and I'm going to run that script. This is the same way we created, the koan script and the let's see here, and the student script the other night. So winter 2026. And there is a create first project script. Yep, there it is. Great. I'm going to run that. And what this will do is create a new Maven project to get you started with the first project, and it'll be in a directory called phone bill. Okay, so now if we do a git status, great, we see that the pom.xml has been modified, again, like we saw last night. Now there is a phone bill module inside of that, and there is a phone bill class. So I'm going to add both of those to GitHub and or to Git, and then I'm going to commit, say added phone bill. No, use two words. Phone bill. Source code project. Yeah, project. And then, I'll push that up. I wonder if I'm going to get conflicts. Let's find out. I don't remember if I've got stuff to pull down or not. One. Okay, good. I took that time. So let's push. Oh, nope. It says that I couldn't push because I have remote changes to be pulled down. So I'll pull stuff down. There you go. And it's merging stuff in. That's fine. I'm just going to take this message. So I'll write and quit out of VI. Cool. Oh yeah, I got some stuff from the I got the changes to student test, and so I'll push up my changes now. I recommend that before you create a project, then that you do a git pull just to make sure you've got all the changes in. Otherwise, you'll have changes that you need to merge. And for me, it wasn't the end of the world, but I know it can get complex sometimes. Okay, so good. I have pushed those changes up. So I'm done with the PSU machine for now. I'm going to go over to IntelliJ, and just for the sake of yeah, just for the sake of demonstration, this is my checkout here. Now I need to update my checkout to get the latest code I just pushed. So I'm going to use the Git update project. I could do a pull also. I like update project. It fetches branches and things like that. I'm just going to merge. Don't want to. I'm not a fan of rebasing. So it's going and fetching the branches, and then it's updating project and stuff like that. Great. It said there were some, files that were updated. And oh, yep, now it's got a phone bill project and it's bold. Great. Awesome. Okay, and now it's got some source code, and this is looking like other projects that you've created. So let's just look at the Java classes. All sorts of good stuff here. So I'm going to go back and forth between this and the PDF for the assignment and sort of explain all this that's going on here. So um, in this project, you'll be working with some of my code that comes from the edu PSCS Joy package. There's a class called Abstract Phone Bill and Abstract Phone Call. And your job is to write two classes. Well, these are concrete classes that are instantiable that are in your package called Phone Bill, which extends Abstract Phone Bill, and Phone Call, that extends Abstract Phone Call. And I believe that out of the box, oh yeah, we get Phone Bill and Phone Call created for you. I'm gonna do? I'm going to just close everything in this tab. We can let's see here, close other tabs, close all tabs in group. Sure. Great. Now I'm going to open this up again. Phone bill. Here's the phone bill class is created for you. It extends abstract phone bill. It takes a phone call associated with it. And phone bills have a customer that is returned by the customer method, and it has methods like add phone call and get phone calls, which are not implemented yet. That's part of what you need to implement. Similarly, phone call has a bunch of methods that are inherited from abstract phone call, and nothing is implemented yet. That's all what you need to do. So as you saw, the phone bill has a customer name and has multiple phone calls associated with it. And a phone call is initiated by a person that has a given phone number at a given time, and is received by a person with a given phone number and ends at a given time. And in this assignment, everything will be modeled with strings. So obviously, the phone numbers will, the name of the customer will be, but also the dates and times. In let's see here, and in project three, you'll start using other classes for that. And so then, uh, right. And so then you might see methods like get begin and get begin time and get end time on the phone call class, and that's fine. Um, I'm just going to pause, get back to my daughter here. Oh, I clicked pause on the screen share, not pause on the recording. Sorry about that. So you got some dead time and heard me texting my daughter. That's okay. Let's see here. So then, yeah, don't for this assignment, don't worry about get begin time, get end time methods. You'll use those in project three. There's also a project one class that contains the main method that is the main method for the program. So what the main method does is it parses the command line, and so the arguments that come in that it passes the main method. It creates a phone bill, adds a phone call to that phone bill as specified, described on the command line, as we'll see here, and then takes that phone call and adds it to the phone bill. And if the dash print option is specified, then it prints the description of the phone call by invoking its toString method. Um, Something really important to note here, and these are in the footnotes, but in project actually in none of the projects do you use standard input. You always read things from command line arguments, not from standard input. And then also, and also there is no data persistence in this assignment. That comes next assignment. So you're not writing anything to files. It's actually kind of dumb, right? What you do is you parse the command line, you create some objects in memory, and maybe you print something out if the dash print option is there. This is purposely simple. We want to take small steps here at the beginning. Don't worry, things will get more interesting in future projects. So here is the command line interface for the phone bill project. You run the main method by invoking java-jar, and so then actually I can just do that here. I suppose I can go to phone bill, and I'll do Maven W verify. Yeah, that'll build the whole thing. And then I'll get back to that in a moment. So you run it, with the target, phone bill dash 1.0.0.jar. And the command line has some optional arguments followed by, optional options followed by required arguments. So the arguments are the following: the name of the customer, the phone number for the caller, the phone number for the callee, so the person who receives the call, and then begin time and an end time. And preceding those arguments are some options, which are optional. So if dash print is the dash print option is specified, then the description of the newly created phone call, the toString value of the newly created phone call, is printed as standard out. If dash readme is specified, then the readme for the project will be printed and the program will exit. And I'll speak to the readme here after I'm done with the assignment. The format of the date and time is a two-digit month, two-digit year, and then two-digit month, two-digit day, four-digit year, and then hours and minutes in 24-hour time. Actually, I said it's two digits. It's not always two digits. So here are some examples of valid dates. You can have 7/15/2026, 10/39, or you can have a two-digit month with a one-digit year, and a one-digit hour, things like that. But remember, these are all 24-hour times, so that's 1 a.m. And phone numbers have the form three numbers dash three numbers dash four numbers. Just a note on this. A big part of this assignment is parsing the command line and parsing phone numbers and parsing dates. And so then I we'll talk about testing in a little bit, but this is I recommend that you write lots of unit tests for your parsing capabilities so that their program can confidently handle the various types of updates that are passed in and phone numbers, things like that. So that's the format of the command line. Oh, good, the build was successful, and so now we'll run this. We'll say java-jar target and then phone bill jar, and it prints missing phone bill information, which is actually out of the box comes with project one, which prints missing phone bill information. Oh yeah, and also echoes out the args. So you can say dash print hello everyone, and then it prints out each command line argument just like that. Oh, note that out of the box, it comes with classes like text dumper and text parser and phone build DAO. We'll see those in future projects. No need to pay attention to them right now. You don't need to implement any of them. We'll be implementing text dumper and text parser in project two, and then the phone build DAO in project four. That's the relational database one, which is brand new this term. So we'll see how that goes. Okay, so that's the format of the command line. We'll take questions in class about that. Lots of footnotes. Please be sure to read them. Um, yep, some of these are already highlighted. Yep, important information there. Let's talk about error handling. So again, this project really straightforward. Well, no, not say straightforward. Is simple. It doesn't have things like data persistence and fancy things like that. We'll get to that soon. And so then a lot of what you should handle or what you would focus on is error handling. So if an error occurs, so either there's an error in the data that's input in or an error that happens during processing, the program should exit gracefully. So please actually don't print a stack trace. You'll lose points if you print a stack trace. Don't have the VM just like crash with no information. The whole idea is that part of the assignment is to issue a user-friendly error message when a reasonable error occurs or a reasonably expected error occurs. So, for instance, if the command line has something missing or there are extra command line arguments, and note that if you have a command line argument, if it was spelled correctly, sorry, that starts with a dash. That's before the first program argument, so the owner name. That's considered an option. So anything before the owner name is an option. If the format of the day or time is incorrect, and please be strict with the syntax checking. So even if it kind of looks like a time like 1128Q, that please mark that as an error. Don't try to issue a warning or something and try to guess. Make sure the user is clear in what their intentions are. And don't worry about checking the semantics of the date. So date like February 30th doesn't exist. I'm not going to test with it. So no need to do that. Also, it's an error if the phone number contains anything that's not a dash or a number, or if the format of the day or time is incorrect, or the format of the day or time is incorrect, which is looks like that's just some copy paste mess from up here. Sorry about that, guys. So let's see here. Those are the primary kinds of errors. Of course, there will be other ones that I'll test for too. When you don't have any arguments provided on the command line, then the program should provide a error message, a usage message that actually, that basically it should be more than the command line. Just say a couple of things about what the program does. Just the command line options, more than the command line options. So basically, more than like what's up here. It should also, provide you. It should also provide a little explanation of what the program does. So you know, over the years, I've evolved the assignment here to kind of clarify the nature of what it is I'm testing. Again, the functionality is very simple, and so there's not a lot of I call a happy path, a lot of expected behavior for the or sort of expected positive behavior to do. You parse the command line, you create some objects in memory, maybe you print it out, and that's it. So most of the things I'll test against are some form of invalid input. And this for project one is a big part of what the assignment is and what you'll be graded on. So so then really what it is not only detecting the error, but also conveying back to the user the right amount of specificity and call to action to get the program running. So if like the end time argument is missing, then say so. Don't just say missing argument, right? That's not nearly as helpful. You'll only get partial credit for that. I'll talk about how to submit projects in a little bit, but the way that you submit them is logging on to the CS department's Linux machines and running the submit script, submit.sh with capital P project one. Here again, there's a whole bunch of details about this in the readme.md that I'll talk about in a little while. Um, and just sort of to walk through the files that are created. So then actually I'll just do this in IntelliJ. That'll be more interesting. Um, so we talked about the stuff that's in the source directory. Um, Also want to look at the tests. So there are unit tests for a number of things, like the phone call test. And here are some examples to get you started. And note that some of these you might need to delete because like once you implement get begin time string get begin time string, then this test will no longer pass because get begin time string won't throw an exception anymore. But it does show you how to use the assert throws method, so that's why I left it in there. Same thing, and actually for this one too. As soon as you implement get Cully, then you should delete that test and replace it with a much more interesting and compelling one. And similarly, oh yeah, the README. I will come back to this one in a little bit. Exactly what this is telling you. And again, for now, you can ignore the phone bill DAO and the text dumper and the text parser. Oh, also notice that there are integration tests up here, and I'll talk about integration tests hopefully in class tomorrow. I don't know. That might wait until a little bit later. I might need to publish some bonus content on that. Again, here's how you run the program, and running the Maven package. Um, Phase will create the jar file. If you want to run all of the tests and run the integration test, use Maven W verify. Okay, let's talk about how this grade will be, how it'll be graded. Um, so one piece of feedback that I got, I don't know, last year, I think when I taught, is that after students saw their their initial grades and like what I had the graders deduct points for and the kind of test cases that I use, there was a bit of a surprise. And what they said is that this kind of a that methodology of for grading is a kind of a combination of other things they had seen in other classes. So, there's some classes that will provide you with like, here are all the test cases and make them pass. Okay. And then other times there's like, oh yeah, here's like, a narrative of what we should do. And there's a lot of interpretation. And so then, the kind of the grade or, and then the code is inspected to determine, well, hey, did you meet the spirit of that narrative? Did you understand everything? And I'm kind of in the middle where it's like, yep, there are written requirements. And a big part of like what I expect you to do for the project is to figure out, well, what could go wrong? What kind of inputs ought to be provided, and how should the program behave underneath those situations and implement automated tests, whether it be unit tests or integration tests, that then demonstrate that the program behaves as expected. Now, I don't expect you to guess. If you have a question, ask it. That's also part of the experience is to look at the specification and say, okay, there's something that seems like there was missing, or hey, what about this scenario? Ask me, and I'll gladly provide advice and expectations there. So I don't, I'm not. If this were CS 101, sure, I'd give you a bunch of tests and say, yeah, just make these tests pass. But it's not. You're all upper division students, upper division undergraduates or graduate students, and in the real world, nope, no one gives you like all of the all of the expected behavior. A lot of the times, it's using your best judgment, it's asking others, and I want you to get experience there. So what you'll after you submit it, what I do is I take the submissions, I run them through a series of scripts that will build the project and then run the program with a whole bunch of different command line inputs. And then I give the outputs of running those commands to the grader, and then the grader will assess those. So I don't look at the code. I don't look at the structure of the code or like any internal quality, anything like that. I ain't got time for that. Sorry. And so then basically it's the behavior of your projects that are assessed. And, I don't have a formal rubric defined. I don't know. It just seems, I don't know. I don't know if it's a mental block. I just don't do that. It seems like I'm just giving too much stuff away if I sort of give all these hints in terms of like, well, if this kind of thing counts for that much of the grade. I also want to give the grader enough flexibility to look holistically at all of the program output and say, okay, well, this is what I think overall the grade for the project should be, because you just get one grade per project, not like while each test case is evaluated independently, it's not that deterministic, mechanistic is probably a better word. So, all that being said, some of you might find, the first time you get the feedback, you're a little surprised, but oh, that's how he tested it. Okay, and I'm sorry, that's a natural consequence of me not giving you, all the things and having, a specification where there is purposefully some room for interpretation and questions. Of course, you've got the resubmit if like, you're really unhappy with your grade. But what I recommend that you do is that once you get those test cases back, that you then implement them as integration tests because, well, for project one, you'll see some of those same test cases again for project two and so on and so on. So that way you can make sure that you haven't broken any of the functionality from project one as you begin implementing project two. So that's a lot about project one. Please read over the assignment yourself and ask me questions either in class during Prime Minister's questions or in Slack. Please let me know what you need to know. Okay. That was, yeah, project one. Let's get some of these other handouts, like how to test your projects. So, testing is a big part of software engineering, and it's a big part of this course. We just scratched the surface in class yesterday by doing a little bit of test-driven development. We watched the Uncle Bob video, but on Wednesday we will see more test-driven development. Some of it done by me, and some of it done with me and someone from class as we pair together to implement a simple code kata. And I've in my career, I've really come to appreciate the value of having automated tests because they provide you a lot of feedback and they help you find bugs faster. And find it shortly after you've made the change that caused the bug, and so that way the change is still fresh in your mind, and it's easy to find it and easier to fix it. And that way you also have good feedback that you are on solid ground, have a solid foundation for all the changes that you make going forward. Didn't used to be this way. It used to be that there were some people in an organization that would write code, other people that would test code, and this led to a bunch of problems. Yeah, there was specialization, but also it led to long feedback loops. I experienced this early in my career where it's like I would get bugs against code that I wrote 6 weeks ago. I'm like, I wrote that stuff. I have to go look in version control. I was like, oh, yeah, because that was me. I don't remember anything, and so you had to like relearn everything that you'd forgotten. There was also a lot of disagreement in terms of what the expected behavior should be, because again, the feedback came in late, and it came in after the code was implemented, and so it's like, oh, I think it should work this way, but I'm like, whether QA engineers might say, well, I think this should be the behavior, and the developer would say, but I spent like 4 days implementing that. I don't want to change it, and so then again, these long feedback loops were not good. There was also like this notion of, well, the developers think it's done, so why isn't it ready to ship? And the poor QA engineer is like, well, we haven't validated it yet. Again, these long phases of work, and meant that just it took even longer. Oh, it took longer to determine that it was done and ready for the users to consume it. And then also, there were all too many software development organizations where the people who were tasked with quality assurance or with validation were seen as second class citizens, as if they were, as if their contribution was just sort of like a checkbox. Well, these are the quality inspectors, right? These are the people that make sure that your code works, that your products work as expected, and that people aren't harmed by them. Just like the person that tests the safety of your food or your car or your medical device. So it was not good times, and so I'm really glad that our approach to testing has evolved. And a big part of this is that testing became easier, and it became easier for developers to do. And so then there were frameworks like JUnit that were introduced, and then there were disciplines like test-driven development that came along basically at the same time. Um, that have made testing a part of development. Now, there are still, in many organizations, dedicated QA engineers, but the initial quality of code that's delivered to the QA engineers is a lot higher because it's already gone through vetting. Sort of like the forehead slapping defects don't happen nearly as often as they used to. So, what does that mean for us? Well, in this course, when we do our projects, there are two types of automated tests that we write. There's unit tests, which we saw a little bit of on Monday, and we'll see some more on Wednesday. There's something called integration tests. So unit tests are all about the internal logic of a unit of a program, like a class or a method. They're pretty focused, and they're meant to be small. Integration tests, on the other hand, work with functionality that is spread across multiple units. So multiple classes all working together, and sometimes if it involves big operations in the file system or interacting with a REST API or a database, that's all going to be in an integration test. They're heavier weight. They do more things, but they also take longer to run. So we'll see some examples of this in class, although there are some in the actually there's one here in the code, and I might as well show it to you. The Project One IT. So what the Project One IT does is it uses this code that I wrote called invoke main test case, which gives you a method called invoke main. And what it does is it takes the class, the Java line class, for a project with or a class with a main method, and calls the main method with a bunch of arguments. And not only does it call the main method, but it has a little bit of magic behind the scenes to essentially capture standard output and standard error, and then include that in this main method result object, and so that you can get at what was written to standard error and standard output and make assertions against it. So here is I'm just going to make this screen here. Here is a simple invoke main integration test that invokes main with 0 arguments. This is variable length argument here, and so you can add more arguments to it there. And it then asserts that the text that was written to standard error contains missing phone bill information, which is exactly what gets printed out when I guess up here, when you invoke the main method with 0 arguments. What this allows you to do is to test the logic of your main method. Because what does your main method do? Well, it takes inputs from the command line, and then it writes stuff to standard output and standard error. There's lots of other code that you have that has application logic, but that's sort of the core of what the main method does. I wanted to make sure that people could test that, and so we have the invoke main test case for that. And I hope to show you some examples of that with the student project um, shortly in class. So, uh, for several for a couple of years, I basically asked people to ask the students to write unit tests. I didn't require it, and what I found is that yep, there were some that did, but then some that didn't, and so we didn't get to experience test-driven development in our projects. So I added a requirement to the projects that measures code coverage of the test. So the whole idea is that I use this tool called Jacoco, which which measures code coverage of your automated tests against your main source code. And so then well, I guess I'll show it right here. Um, when Maven is invoked with a dash p greater, it puts it in a special mode that will, among other things, um, uh, calculate the code coverage. So I'm going to run this now. And so and actually this is pretty cool. What it does is it builds your project like normal, but then when it runs the unit tests and the integration tests, the execution is oh, what's the right word for it? Is measured. There's all this bookkeeping that is invoked by this Jacoco tool to determine what lines of source code are actually executed by your tests. And so what this does is it tells you, hey, do you have sections of your code that aren't tested? It's really powerful. It gives you an indication. Oh yeah, if and it gives you an indication of how much code was covered. And as it turns out, not enough. So for the class, you are required for the project, you are required to have at least 75% of executable instructions covered. And as we can see from this warning, which is really an error in this case, because I've got the fail if less if insufficient code coverage option set. Only 62% was covered. And okay, well that's good to know, but it doesn't tell you very much. However, there is a report that's generated in this target site Jacoco index.html file that then will give you information about what code is and is not covered. So we're looking at missing instructions here. We've only got 62%. And so you can drill down into the phone bill DAO. Oh, isn't that interesting? Huh. Yeah. Okay, guess what? I don't have, okay, that'll be interesting. Oh yeah, because the main method isn't called. Okay, good to know. Um, we might need to fix that. But if we look at the Project One main class, here we have there's not a lot of code, but look, this code here is validate time is never invoked, and there aren't any tests that invoke this loop where we print out all the arguments. And actually, hey, just for the sake of showing the change in code coverage, um, I guess I'll leave that there. Let's just take a moment and add let's see here, add a new test that says, um, let's see here, test only customer name. That seems interesting. And so let's see here, command line arguments are echoed to standard out. Thanks. Okay, so then we'll just say the following. We'll say main method result result equals invoke main with one argument, which will be, well, that's all neat. Okay, that's not right, but it's neat. Hello. Oh, and actually, I'll put this into a variable. So I will use the refactor introduce variable to call it, first argument. And then let's see here. Oh, was it standard output or standard error? I think that's right. Let me just go back and check on the what system.out. Yep, so it points to standard output. Okay, oops. Oh, there we go. And so then, yeah, I would. Oops, it looks like it needs a brace. Um, so yeah, so this is basically saying, hey, invoke my main class with one argument and assert that the argument is written to a standard out. I think this is a pass because it's just testing the code the way it is. I'm going to run it here from IntelliJ, which you can do with the integration tests. And I'll go through and good, that passed. So I'm going to run it again. I'm going to do a clean verify here. I'm going to run it and see if this makes any impact on my code coverage. And if anybody's having problems with their code coverage checks not meeting, oh yeah, I went from 62 to 65. Cool. And now I'm going to go back here. I'm going to refresh the page. And I think we'll see now that this line down here is covered. Let's find out. Oh, it is. Great. This went green. So, right, it went green when I refreshed because now that line of code is covered in your tests. And sorry, back what I was saying, if anybody is encountering problems getting their code coverage to pass because of things like the phone bill DAO test or phone bill DAO or whatever, feel free to comment stuff out, and then we'll get back to it later. That's okay. Anyway, that's how code coverage works, and that's how integration tests work. I'm just going to commit this. So I'm going to say I added an integration test to demonstrate increased code coverage. You do not need to do this. As a matter of fact, don't do this because you're going to remove this capability, right? Printing stuff to standard out is not part of the assignment. If you do that, I'll instruct the grader to dock some points because you have extraneous program output. Anyway, so you need to write enough unit tests and enough integration tests to get 75% code coverage. Oh, and note that every source test must have, or sorry, every source class must at least have, must be invoked by at least one test. It must have some coverage, right? So you just can't have like dead code hanging out there. There is an error message. If you see this error message in IntelliJ, I think is usually where you see it. Just do a Maven clean. It will clean it up. Um, yeah, and sometimes or you need to rebuild the project from IntelliJ, but it's an interaction between the command line and IntelliJ. Let's see here. Oh, I guess there's a couple of things to note. Um, oh, there's right. If you end up having static fields in your main class that are mutable, that are non-final, this is almost always causes bugs, and I'm just going to prevent you from doing it. So if you go to run if you do invoke main with a main class that has mutable static fields, it's going to fail. So don't, and I get because the whole idea is like don't store program state in static fields. And note also that please do not invoke system.exit because that'll mess up your integration tests. You'll be exiting out of the VM that runs your integration tests, and the VM won't like that. The whole framework that runs the integration tests, which is essentially JUnit, will get confused. So there's please do not invoke system.exit in your code. And here are some signs that maybe you have. Yeah. So these are some notes on how to test your programs. Bottom line, testing is required. Oops, there will be a I run one of the tests is to run with this -p grader and the verify goal, and I'll be looking to see, and the build will fail unless you have at least 75% code coverage. Okay, next handout, how to document your projects. So yes, interestingly enough, there's more handouts about the requirements of the projects than the project itself. Don't worry, this will apply to all of the projects. So we're just learning a lot of it up front here. So it's the same way that testing is essential to software development. So is documentation, right? You need to communicate what you're doing. You need to communicate why you're doing it. Oftentimes to your future self. I have to admit, there have been so many times in my career I'm like, oh my gosh, I'm so glad I wrote that down because, I'm not going to remember all of it. I'm not going to remember why I made certain decisions. I'm not going to remember exactly, what an API is used for, or some hard to express requirement of the code. So, and especially, as a student, you're still figuring things out, and you have a lot more experience in your lives, working with a spoken language or a written language than a coded language. So, it's good to put the two together. And so there are a couple of mechanisms that we'll use in this course to document various aspects of our code. The first one is called a plan of attack. So a plan of attack is something that you do before you really break ground on the project. It's a design document, and basically what it is a plain text email that's in the body of send me in the body of the email. Please don't send me a PDF attachment. Don't link to me a Google Doc. Just put it in an email and send it to me. And what a POA is a couple of paragraphs. So don't send me code or pseudocode. Just write it out in text that describe how you'll implement your project, or what it is and what it does. Maybe and hey, any thoughts or observations you have about it. Any sort of big decisions that you haven't made yet, or anything you think is tricky that you'll need to work around. The goal here is to, really to force you to think and do some writing about your project before doing it. So, this prevents you from starting it from the last minute, or, getting, wait, or getting like 2 hours before, the assignment is due, only to realize there's a fundamental concept that you haven't thought about, or a fundamental problem that you haven't worked out yet. So the POA itself, that email, please send it to me no later than 72 hours or 3 days before the project is due. So since most projects are due Wednesday at 5:30, this means that it's Sunday at 5:30 is when the POA is due, the Sunday before the project. And late days, POAs aren't eligible for late days. The For the project, yeah, sure. If you need a couple, if you need an extra day there, you got a couple. But give me the POA before Sunday night. Please email it to Whitlock at cs.pdx.edu. Of course, you can use either my Gmail or my other pdx.edu account also. What's most important is that the letters POA and the name of the project are in the subject. So like POA for project one. This is important because I filter all the POAs out into its own mail folder so I can grade them all at the same time. And also, it keeps my inbox a little tidier so that I'm more likely to see other emails that you will send me. But as a result, if you have something important for me to send me an email, don't put POA in the subject because I won't see it for a couple of days. And note that if your POA is late, I'm not, you won't receive credit for it. So the plan of attack is one tool that we have for documenting code. Another is Java doc comments. So actually, this is something that I guess we can talk about now. So you may have noticed that in the source code, actually, there's stuff here. There are these comments that begin with slash star star and end with a star slash. We saw it here in this test. We also see it, a phone call does have it, does phone bill have it? Let's see here if we've got a good one. Actually, I know student does. I'm going to open up student. Yeah, student has Java comments all over the place. And so then let's see here, program elements like classes and methods and fields, if they're preceded by one of these Java doc comments, it means that this is documentation for like the class that follows it. Or here is bigger. Here is here's documentation for the constructor that follows it. And as you can see, there are these tags within JavaDoc that allow you to describe specific arguments to the parameters to the method, to the constructor in this case, or a method. And there's this tool called JavaDoc that will analyze, that will read the source code and create human readable documentation from it. So if I go back to the student directory and I use Maven W, JavaDoc, this is the JavaDoc plugin for Maven, the JavaDoc goal. What this will do is this will build HTML documentation for the for the student code here. That was pretty fast. Maybe that's okay though. Target site. Oops. Target reports. API docs. There we go. That's HTML. There's only one project. There's only one class in this project, so it's really quite simple. But here we've got documentation for the student class, and the description is this class represents a student, which is derived from this JavaDoc comment right there. And so now we can go into that student. And this JavaDoc looks just like the standard JavaDoc for all classes. Oops, I'll go open that up in its own tab. And so then this same tool, the authors of the Java API use it there also. And so then you get consistent styling, and you can link between them, right? So as we saw with our student project, student extends human and mammal and animal all the way up to object. And so actually I haven't linked off to my JavaDocs too. And we'll see more how to generate all this stuff and publish it to github.io at a later time. But this is a cool thing that you can do with Java. It makes it really easy to document your source code. They have nice tools for this, et cetera, et cetera. And so you can click on the student constructor, and here's a description of the student constructor, which has all this description, all this text about the parameters. And again, that comes directly from this this comment right here. So that's what JavaDoc is all about. And here's a link off to get all sorts of information about it. And when I grade your projects, I'm going to run this command here again with the -p grader. This is the Maven profile for the grader. When I run it here, instead of generating HTML documentation, which would be slow for me to grade, what it does is it uses some code that I wrote, something called a doclet, that prints out some simple text that is derived from the API documentation. And this way, the grader can look through this and make sure and validate that yes, your code is documented as expected. So, oops, and just to be clear, let's see here. The requirements are every class and every method that you write should have a JavaDoc comment. And again, I'll validate that by running this Maven W-P grader JavaDoc JavaDoc to see all of that. Finally, there is the README for your projects. So you know the plan of attack. You did that before you didn't post the coding, or well in advance of submitting the assignment. There is the API documentation, the JavaDoc comments that you've added internally to the code. But as you may recall, in the project assignment, there is a -README option to the command line. And when -README is provided, what your program should do is print out the README, which is a description of what the project does and what it does, and also who did it. So let's see here. It should have your name and the name of the assignment, more than just command line usage, right? Have it print out a some information about the program, what it does. And note that when you see -README, all the program does is print the README and then returns, right? No additional command line parsing. It doesn't try to do anything else. Just print the README and exit. Now, the README is a reasonable sized chunk of text. I don't know, 50 lines. I don't know, maybe more, maybe more. And as we all know, writing big pieces of text inside of source code is icky, right? It's you end up with like code that's spread out over a whole bunch of lines, and formatting can get really messy. So there was let's see here, that there was back in the phone bill, there is I believe, a Project One. Nope, I'm sorry, it's a Project One test. So the integration test, the unit test here. Um, that gives you a clue of how you can how you can read your README from a file. So here in the resources directory, there is a file, and this is the source main resources directory. There's a file called readme.txt. And what I encourage you to do is to update this file with the contents of your README. Resources, you'll learn about them in, maybe the text and date, probably the text, the working with text lecture. Um, Resources are files that are bundled with the jar file that aren't executable code. They are instead something like, well, a text file or an icon or a sound that gets played back by your application. So it's not code, it's basically a file that then is part of your application. And Java contains APIs for reading the resources and then doing things with them. And that's what the Project One test does. So it uses this method called get resource as stream from a class object that will basically say, hey, give me the file, or go look for the resource named readme.txt that's in the same package, the same directory as the Project One class. And so since Project One is in edu pdxcs joy whitlock, that's what Project One is. And README is also in a directory that corresponds to edu pdxcs joy whitlock. It'll find it. And so then this returns thing called input stream that you'll learn about in the I/O lecture. And make sure that it's not a null value, because if you can't find it, it'll get a null. And then it gets something called a buffered reader that allows you to read, in this case, the first line of it. And and asserts that, the one line that's read from it, or first line that's read from it, contains, this is a README file, which is exactly what we would expect here, because this is a README file. So I encourage you to study this code, and move it someplace into your into your Project One main or someplace else where it can go and read the resource for the README. So when -README is present on the command line, go call code that looks a lot like this, probably without the asserts, and print out the README. I've had some students in the past that have kind of struggled with this, and it's a kind of much for the first assignment. So, hey, if you're spending more than like 20 minutes trying to figure this out, no, it's no problem if you just like devolve back to, like, I'm just going to have my README as literal strings inside my Java code, and we'll work it out. Probably by the time you get like Project 3 or something, this will all make sense. But this, I think, keeps it simpler, and it'll get you off to a brisk start. Okay, that was the README. So again, there are three forms of documentation for each project: the README, the Java.comments, and the plan of attack. Okay, finally, we've done testing, we've done documenting, talk about Project One. Finally, let's talk about, since I've got you all, let's talk about how to submit your code. And this is, I guess, for reasons described. The submit process is described in the README of the repository. Let's see. How do I submit my projects? There it is. Okay. So I might have mentioned this before. One of the big aha moments I had a little while ago is that in order for me to, well, one of the things that helps me provide what I hope you feel is good support and good service to you all as students is the fact that I have automated the drudgery. I don't want to be spending time on things that are slow, are error prone, that could be automated. And so I've automated them. And one of the things that I've automated is the process by which projects are submitted and, for me, are extracted, from that submission process. So what I did is I wrote a Java program that will that you tell it, hey, go submit these files. It'll take those files and put them into a zip, and then emails the zip to the grader account. And then I have on my end code that will go and get those emails from the email server, extract the attached zip file, maybe they're jar files, can't remember, and then sort of get everything ready to be graded. This saves me a tremendous amount of time and actually really helps helps things like students who resubmit their projects, and so I can provide them with feedback very quickly. And all of this is driven from your side from the submit.sh script. So so just be clear, you don't submit projects by uploading something to Canvas or emailing me or I suppose no one puts them on, puts their code on floppy disks anymore, and things I can't believe that we used to do back in the 90s. But anyway, and instead we use the submit.sh script. The submit.sh actually will do things like build your project, and it'll also complain if you have local changes that aren't committed. I have these checks in here because I've added them over the years because students have had problems. Like there have been, students that have submitted changes that weren't in GitHub, and so then there was a problem, and I'm like, I'm seeing this problem, and the student's like, I don't see that problem. It's like, well, it's not there in GitHub, and so no wonder you're missing a change. So I added some checking to the to the script. But there is a lot of text that goes by, and actually, maybe I should just show it to you. I can submit I can log on to the PSU machine. So like all of the scripts, they must be run on the PSU machines. I'm going to go to, let's see here, Portland State. No, sorry, I'm going to go to Dave Whitlock, Joy of Coding, Winter 2026. I'm going to run the submit script. I'm just going to submit project one. And oh yeah, it does a git pull. Another thing that I've learned the hard way. It's like, oh yeah, you want to make sure. Oh, the above revisions have not been. Oh yeah, okay. It makes you do a git pull first, so that's good. Trust me, it is. I'm just gonna do this, so I only need to enter my password once. Well, if I type it correctly. Nice. Now I'm going to do a git pull, which you definitely want to do right here again. It's something else that where it's like students forgot to do a git pull to get their latest changes in, and things failed, and they submitted different code than they expected. I'm going to run the submit script again. Good. It's getting the latest changes. Now it's doing the Maven build. It's running phone bill. It's telling me all sorts of things. It's going to run with the -p grader, and so it'll tell me if I don't get enough code coverage. So, resist the urge to sort of ignore all this stuff going by. Make sure that it is, building what you think, what you expect, and that it builds cleanly, that you get a successful build, even though it might, whiz by on the screen. Oh, download some stuff. That's nice. Oh yeah, there was the Java doc. It runs that. Yep, we saw the build failure go by. I know it's pretty quick, but you gotta scroll up. And the build failed because, yep, again, we only got 65% code coverage. Okay, for the sake of demonstration, great. I'm gonna do that. Oh, it's oh, interesting. Okay. So it's complaining about a couple of things that aren't being submitted. So, okay, like a site XML file and a package HTML. That's fine. And now it tells you here are all the files that are being submitted. All sorts of good stuff. And it will, oh, you can provide a comment with like the dash comment. Do I have an example of that here? Yeah, like a dash, or oh, sorry, not a dash comment. You just provide it as a second argument to the submit.sh. Oh yeah, and here's something that's very important. So, on like, I don't know, probably the second day of class a couple of years ago, one of the students asked, "Well, about how long should I expect these projects to take?" And I thought about it. I was like, "Well, I've got no idea. I mean, I've never done the projects, and if I did, it'd be super easy for me, right? So I was like, oh, I can't answer that question. It's like how much how long I think you should, take it, but that's not accurate. And so, I thought about it, like, wait a second, I can collect data. And so then when you submit a project, it'll ask you to estimate or sort of figure out about how many hours you spent on it. Just to be clear, it's not part of your grade, it's not required or anything like that. This is just to inform what future students well, it informs actually some information that I'll show you quickly over here. I'll show you shortly on the README in the repository. So let's just say I spent, I don't know, 17 hours on it, and then say, yeah, do I wish to continue? Sure. And now it's submitting the project off to the grader, and it's sending me a receipt. Oh, it also puts in a Git tag on this revision to say that, hey, I submitted project one on this date. And this is useful uh, if you need to go back and then make a branch from your repository off of this submission. So anyway, it's a nice thing that it does. And so that's how you submit your code. It should be pretty straightforward, but do be sure to look at all the stuff that scrolls by to make sure that the output of the build is what you expect. I think it's basically all the stuff that is covered here. Oh yeah, a couple of important notes. Um, your pom.xml is not submitted, which means that you can't modify your pom.xml. So no, you can't add dependencies. You can't have, oh, I want to use this Apache library to like do the command line parsing. Nope. You do it yourself. And I know that's not the way we do in the real world, but the whole idea of the first project is to do command line parsing. So figure it out. You can submit multiple times before the due date. It's not a problem, but remember, I've got to extract everything each time. So, be appropriately judicious. I don't think we have I've never had a student that's like submitted so many times that's caused me a problem. And the submission process is has the official timestamp for the submission. So this is what determines whether or not the project is late. As remember, my policy is not to accept late work. That being said, in practice, I want to see your work. And hey, if it took you an extra day, or hey, if you're getting behind or whatever, let me know. I don't want to be surprised. And so if you give me a heads up, it's like, hey, listen, I'm gonna need another day. It's gonna be late. I'll try my best to accommodate you, but only up to a point. I want to make sure that it's that people have equal time and equal fairness in terms of the amount of time people have to do their projects. And here's some more information about what the submit.sh script does, and I think we've covered most of this stuff here. Two, and oh yeah, if you want to push your tags, here's how you do it. And here's a little information if you end up wanting to create a branch off of a submission so you can go back and fix things. Here's how to do all of that. Yeah. Now, again, for a couple of years now, and I wish I'd been doing this all along, we've been gathering data about how long it takes to do the projects. And so we have a number of data points now. So we have 168 submissions for the first project, the app classes project. And so you can see on average it took 21 hours, and it ranged from someone one time who said, oh, it took me 3 to sometime, 2, sorry, for some person it took 60. And here again, these are self-reported, and so then your results may vary. And just because you're on one end of the distribution isn't good or bad. I don't. Again, there's no judgment, there's no grading. But hey, in terms of planning, yeah, plan about 20 hours to do these first couple assignments. Actually, every assignment, the average kind of averages out. Rest takes a little bit longer. But somewhere between 20 and plan for that rest one, because it's been known to be pretty tricky. Although again the median is around 20 hours also. So okay, this is what the data has been telling us over the years. And note, well, the XML assignment, actually, that's kind of been deprecated. I should take that out of here. But it's only in the 11-week version of the course. We're going to replace, we're replacing XML this term with relational databases, which I think will be much more relevant and interesting to people. So anyway, and then just sort of caveat emptor. This is self-reported data, and so it's only as accurate as people want it to be. And so I don't know if people are inflating it either way, but this is what people have reported, and we can sort of look at the distribution to see that yeah, most people are in the the 12 to 25 hour range on on the projects. Okay. And I think that's it. And that was a lot. And so I'm guessing that I talked for the better part of an hour. And I'm so glad that we're not doing this during class tomorrow. I would have just skipped over a lot of stuff. I'm glad I got to show you things like here's how you run the Java doc, here's how you do the code coverage. And it's all important information to have. So I appreciate you taking some time outside of class to catch up on all this stuff. It's important for you to know. Of course, I'm happy to answer any questions either in class during Prime Minister's questions or in the Slack channel about all these things about your projects, right? What the project one specification, what the expectations are there, expectations for how to test and document your projects, and then also the process for submitting it. So thanks again, everybody. Look forward to seeing you in class tomorrow. And until then, take care.